Hello students, Econometrics is not just theory. Right now in Fufore local government area of Adamawa State, along the famous Data-Ribadu irrigation scheme, rice farmers have just finished their harvest. Their farms are divided into plots, each plot measuring 20 meters by 20 meters. So today we are going to take their real farming data and then apply correlation analysis to it step by step. Welcome to BioSTEM Academy. Let's get started. So what is correlation analysis? So correlation analysis measures strength and direction of relationship between two variables. Correlation analysis measures or determines the strength and direction of relationship between two variables. Now it means correlation analysis is a statistical tool that measures the strength and direction of a linear relationship between two variables. So in simple terms, correlation analysis tells us when one thing changes, does the other thing changes with it? It tells us when one thing changes, does the other thing changes with it? How strongly is the change? And in which direction? Is it negative, the same direction, or opposite direction? Positive direction or opposite direction? And in correlation analysis, this small r is called the Pearson correlation coefficient. Pearson correlation coefficient is small r. In correlation analysis, small r is Pearson correlation coefficient. So the result of correlation is called small r. And this Pearson correlation coefficient falls between 0 and 1. If this r is close to 1, if r is close to 1, that is positive 1, it means, or it indicates strong positive relationship. If r is close to -1, this indicates strong negative relationship. If r is close to 0 or 0, there is weak relationship. So r -1 is less than or equal to r, and r is less than or equal to +1. That is it. Now, how do we calculate correlation, Pearson correlation coefficient? How do we calculate the Pearson correlation coefficient? The formula is given by, the simplest formula is r, small r is equal to SP over square root of SSX sum of square x dot sum of square y. Alright? SP over square root of SSX dot SSY is the formula for calculating the Pearson correlation coefficient, where SP is sum of cross product. SP is the sum of cross product, and this SP has its own formula too, which is equal to summation xy minus summation x summation y all over n. Then SSX. Sum of square x is given by the formula summation x squared minus summation x all squared in bracket all over n. Then this one, sum of square y, SSY, this formula is summation y squared minus summation y all squared all over n, right? Summation y squared minus summation y all squared all over n, sum of squared y. Now the scenario, let's look at the scenario. Let's look at a scenario, the Ribadu rice farm scenario. This is Ribadu rice farm scenario, rice farm scenario, right? Particularly in the Fufore local government area of Adamawa State during the dry season harvest. The Ribadu irrigation scheme, Fufore local government area of Adamawa State, is one of the most productive irrigated farming zones in northeast Nigeria. The farmland is divided into standard plots, okay? Their farmland is divided into standard plots. Each is measuring 20 meters by 20 meters. Each plot is measuring 20 meters by 20 meters. Let's do the calculations somewhere here. Let's do the calculation here first. Ribadu rice farm scenario. As I said earlier, the Ribadu rice irrigation scheme in Fufore is one of the most productive irrigated rice farming zone in northeastern Nigeria. The farmland is divided into standard plots or regular plots. Each plot is measuring 20 meters by 20 meters. That is for every one plot. Okay, one plot is 20 meters by 20 meters. So farmers are allocated different numbers of plots depending on their farm sizes. One plot is equal to 20 meters times 20 meters, that is by 20 meters, right? And then the standard fertilizer is 3 bags of NPK, 3 bags of what? NPK, and then subsequently after NPK then follows the application of 2 bags of urea fertilizer, so giving a total bags of how many? 5 bags, right? 2 plus 3 plus 2 is 5 bags, and this 5 bag each bag is 50 kilogram. So if you multiply 5 times 50 kg, is going to be 250 kilogram of what? 250 kg of fertilizer, total fertilizer application, right? And now and the normal yield is 40 to 45 bags of paddy rice, 40 to 45 bags of paddy rice, and we're talking about for 50 plots, for an average of 50 plots. For every 50 plots, a farmer applies 3 bags of NPK. For every 50 plots, a farmer applies 3 bags of NPK, 2 bags of urea, and then 5 bags, that is in total. Understood? Now look at it. One plot is equal to 20 meters by 20 meters, right? And then this one plot gives 400 meters squared. The area for one plot is 400 meters squared, and area for 50 plots is equal to x, right? Now x will give you 400 meters squared times 50 plots all over one plot. Simple calculation. 400 meters squared times 50 plots all over one plot. So this plot will go plot. So x 400 meters squared times what? 50, and this gives us what? 20,000 meter squared. And 20,000 meters squared is the same thing as 2 hectares, right? 2 hectares. 20,000 meters squared is the same thing as what? 2 hectares. Now back to our Ribadu irrigation scenario. Ribadu rice farm scenario. Now consider a farmer. Consider a researcher. A researcher surveyed 8 rice farmers at the Ribadu irrigation scheme for a local government area of Adamawa State. And then after the just concluded 2026 dry season harvest, this researcher recorded a total fertilizer applied, or the total fertilizer applied in kilogram, in kg, and the corresponding rice yield in bags, right? And the corresponding rice yield in bags for each farmer as shown below. Now, researchers surveyed 8 rice farmers at the Ribadu irrigation scheme, Fufore, Adamawa State. After the 2026 dry season harvest, he recorded the total fertilizer applied in kilograms and the corresponding rice yield in bags for each farmer as shown below. So these are the corresponding farmers. Farmer A to H, that is 8 farmers. Fertilizer 100 kilogram, 125 kilogram, 150, 175, and so on. Rice yield after applying 100 kilogram of fertilizer, this is the number of bags. Okay, now we are required to calculate the Pearson correlation coefficient. Calculate the Pearson correlation coefficient, get the coefficient determination, that is R squared, and then finally we interpret our results in the context of rice farming in the study area or in Fufore local government area of Adamawa State. Now keep it separate and so the first thing we do in this question, the first thing we must always do is to construct our working table. First thing we do is to construct our working table. We need how many columns? 5 columns. Now we need 5 columns. X, Y, X squared, Y squared, and then XY. How many columns? 1, 2, 3, 4, 5. So we need these columns. So our x is 100, 125, 150, 175, 200, 225, 200, 225, 250, 300, 250, and then 300. Y 16, 20, 24, 16, 20, and what? 24, 28, 32, 36, and 41, and finally 49. Now we have x, we have y. Then how do we get x squared? Just square this 100. If you square 100, it's going to be 10,000, right? And then squaring 125, 15625 using a calculator, 15625, right? And then next 150 squared is 22,500. 150 squared is 22,500, right? And then 175 squared, 30,625, 3625. 200 squared is 40,000, and then 225 squared is 5625, 5625. Then 250 squared is 62,500, 62,500. Then our calculator, 300 squared is 90,000, 90,000, right? Now y 16 squared is 256, yes. 20 squared is 400, 24 squared is 576, 28 squared is 784, and then next is 32 squared, 1024. Next is 1296, and next is 1681, and finally 2401, 2401. Now xy is x times y. 100 times 16 is 1,600 or 1600. Here we have this times this gives us 2,500, yes, using calculator. Next is 3,600, 4,900, 6,400, 8,100, 14,250, and finally 300 times 49 gives us what? 14,700, right? So now, having completed filling the tables of the 5 columns, let's sum each column. So using a calculator, 100 plus 125 plus 150 plus 175 plus this, and we get here summation x gives us 1,525. And then this one, summation y, adding this together from 16 to 49, that is summation y we get 246. Next, summation x squared. Summation x squared. That is this summation x squared. Summation x squared. That gives us 321,875. Then summation y squared. This summation y squared. 8418, and then summation xy cross product gives us 52,050, right? 52,050. Then n is equal to 8. Why is 8? Because we have 8 rice farmers surveyed in the research. Now, what we are going to do here is, next is let's calculate our R. R is equal to SP over square root of SSX dot SSY, right? And what is SP? You say it is summation XY minus summation X summation Y all over N. Now summation XY. I'm looking at the way is XY. Summation XY 52,050 minus summation X 1525 times summation Y 246 all over N H. So 52,050 minus this times this gives us 3,75,150 all over 8, and this is 52,050 minus this divided by this gives us 46,893.75, and subtracting this from this we get what? 5,156.25. So this is our SP, sum of cross product 5,156.25. Now SSX is equal to summation x squared minus summation x all squared, right? All over N. So summation x squared, let's cut it, 321,875 minus summation x is 1525 all squared all over 8. So we get 321,875 minus the square this, we get 2,325,625, and divided by 8, then we get 321,875 minus this divided by this is 290,703.125, right? So this and this is 3,171.875. So this is our SXX 31,171.875. So we have it like this, right? Next is what? SSY, summation y squared minus summation y all squared all over N. So summation y squared 8418 minus summation in y 246 squared all over 8. So 8418 minus square 246 we get 60 5768 square 246 we get 60 5168 then over 8. So 8418 minus this divided by this, you get 7564.5. So subtracting this from this, the answer is 853.5, right? 853.5. So this is our SSY, 853.5. Now we go ahead and input this here. R is equal to, from the formula, R is equal to SP over square root of SSX dot SSY. So what is SP? SP is 5156.25 5156.25 over square root of SSX this 31171.875 times SSY 853.5 853.5, and this gives us 5156.25 all over. This is 26,605,195.3125, right? All inside this curve. So this is 5156.25 as our numerator all over square root of the denominator. The square root of the denominator will give us 5158.02. So dividing this by this, we get our R is equal to 0.9997. Approximately that is 0.9997. This is Pearson correlation coefficient, right? So we've now answered the first question. Calculate the Pearson correlation. We have answered the first question. Calculate the Pearson correlation coefficient. So the Pearson correlation coefficient is 0.9997. Okay. So this is almost perfect. Now the most important thing is the second question 2. This is the first question, right? Calculate the Pearson correlation coefficient. We calculated it, and the second one is just coefficient with termination. How do you get this? You get this when you square your R, square R. So R squared is equal to coefficient of determination, right? So when you square R, R squared is equal to 0.9997 squared, and this will give you 0.9994, right? And this is 99.94%. 99.94%. So this is the value of coefficient of determination, and this is, you usually see this when you come to interpretation. So the R value of 0.997 is positive. This means that fertilizer application arise yield move in the same direction. Okay, this indicates that fertilizer application arise yield in Ribadu, that is in the study area, in the place where the research was taking place. Fertilizer application arise yield in the Ribadu irrigation scheme move towards the same direction, So when farmers apply more fertilizer to their plots, their rice harvest increases. Whenever farmers apply more fertilizer to their plots, their rice harvest increases. This is consistent with the agriculture or agri-related, policies. Now the strength is 0.9997. This strength is extremely close to 1, so which means that the relationship is almost perfectly strong, okay, between fertilizer application and yield. R squared 0.9994 means that 99.94%, okay, 99.94%. Now we're trying to interpret, that is the last question, okay. This is the interpretation. 99.94% of all variation in rice yield among the 8 farmers in Fufore, particularly in Ribadu irrigation scheme, is explained by the quantity of fertilizer they applied. 99.94% of all variation in rice yield among these farmers is explained by the fertilizer they applied. Only 0.06%, only this infinitesimal quantum of percent is attributable to other factors like labor, irrigation, seed variety, and other factors that may come into play. Now finally, this indicates or tells us that when we subsidize fertilizer, we increase our output. By subsidizing fertilizer, output will be increased. So whenever fertilizer is subsidized, then our yield will increase. Finally, subsidize fertilizer and then increase yield or output. Now econometrics lives in our farms, in our communities, in our everyday lives, okay. If this video helps you, like it, share it with your classmate, and then subscribe to BioSTEM Academy, okay. And finally, if based on this interpretation and this result, if the Adamawa State government, especially the Fufore local government area authority, or the local government authority in Fufore, or any other agri intervention program wants to increase rice production at the Ribadu irrigation scheme, then this analysis provides a statistical justification to fertilizer subsidy targeting smallholder farmers in this study area in Ribadu. So finally, drop a comment, tell me your stage. See you in the next video. Thank you.